In this lesson, you will be multiplying radicals with variables. Let's take a look at some examples to better explain this concept. Recall from a previous lesson how to simplify a radical with a variable under it. Let's start with radical x to the fourth. Now recall that taking the square root of a variable simply means dividing its exponent in half. So the square root of x to the fourth is simply x squared. X to the fourth, or any variable with an even numbered exponent, is considered a perfect square because even numbers can simply be divided by 2. Looking over to the right at radical x to the fifth, notice this time that the exponent is an odd number. So what we want to do here is we want to understand that x to the fifth means that you have x multiplied by itself 5 times. So what you want to do is underline as many as you can with 1 left over. Because being that this is an odd number, by underlining the first 4, you now have x to the fourth and x. So at least part of this is a perfect square. So the square root of x to the fourth, if you just divide its exponent by 2, is x squared. The remaining radical x will simply drop down into the answer. So the final answer is x squared radical x. Now let's see how we can use this to apply it to multiplying radicals with variables. Here we have radical x times radical x cubed. Now we can combine whatever is under the radicals. Now recall when you learned about multiplying variables from the properties of exponents that to multiply x times x cubed, you simply add the exponents. This would give you radical x to the fourth. Therefore, because the exponent is even, this is a perfect square. And if you simply divide it by 2, our answer would be x squared. In this next example, we've got 2 different variables. So the first thing we want to do is combine them together into one by adding the exponents of each common variable. So for the x, we will add together the 2 and the 1, so we have x cubed. Then we will add together the exponents of the y's, so we have y to the fourth. Now we're ready to break this down. This is the same as saying x times x times x, and then y times y times y times y. For the x's, since it has an odd exponent, we want to split it up into x squared and x, so that at least part of it is a perfect square. Now the y's we can just leave alone as y to the fourth because its exponent is already an even number, which means it's already a perfect square. The square root of x squared, if we divide its exponent by 2, is going to be 1, or just x. Going over to the other perfect square, if we divide the 4 by 2, we will get y squared. So only radical x is not a perfect square, and we will just put that at the end of our answer. So the final answer is x, y squared, radical x. In this problem here, we add numbers to the radicals. So we have the 2 and the 3. So again, we want to multiply everything under the radicals and combine them into 1. This negative that's outside the radical, we will simply drop down, and then whatever ends up outside the radical, we will include the negative with it. So first let's combine everything under the radicals into 1. Multiplying the 2 and the 3, we get 6. To combine the x's together, we add their exponents, getting x to the fifth. Then we'll add the exponents of the y's, getting y squared. Now we notice that the x has an odd numbered variable. So we're going to want to change that so that at least part of it is a perfect square. So if we have 5 x's, we will group 4 of them together, so it turns out that we have radical x to the fourth, radical x. So we can at least take the square root of part of x to the fifth. Excuse me. Don't need the radical symbols under a radical symbol, so we could just put x to the fourth, x. And then the y already has an even numbered exponent, so we can keep that as a 2. Now if you look at what's under the radical, we have 2 perfect squares. So the 6 and the x will remain under the radical because the 6 cannot be broken down any further using a factor tree, and neither of them are perfect squares. So let's take the square root of x to the fourth and y squared by dividing their exponents by 2. This leaves us on the outside, besides the negative sign, we would have x squared, and for the y, when we divide its exponent by 2, we would simply have y to the first, or y. In this last problem, we will approach it in a similar way as we did the last. We will drop down the negative. Now, let's go ahead and multiply 45 times 8 over to the side and make sure it does not come out to be a perfect square. So 5 times 8 would be 40. Then 8 times 4 is 32. And 32 plus 4 is 360. Now, is 360 a perfect square? You may or may not know, but in fact it's not. So you have the choice. You can either break down the 360 using a factor tree, or you can go back and separate out the 45 and the 8 and factor them separately, which is what I'm going to do. So 45 breaks down into 5 and 9, and 9 breaks down into 3 and 3. 8 breaks down into 2 and 4, and 4 breaks down into 2 and 2. So altogether, we've got 3 2's, 2 3's, and a 5. So if I underline my pairs of 2's and 3's, they will become my perfect squares. So let's go ahead and put them under the radical. So we have a 4, which is a perfect square, and a 9. Then we have our non-perfect squares, the 2 and the 5, and this makes 10 when we multiply them together. Now let's look at our variables. For our variables, if we add their exponents together, we will have x to the 8th, which is a perfect square because its exponent is an even number. For the y's, we get y to the 7th. Now y to the 7th can be broken down into y to the 6th and y, so that at least part of it is a perfect square. So let's go ahead and do that. Now I'm going to underline all my perfect squares because once we take their square root, they will move to the outside of the radical with the negative sign. So the square root of 4 is 2. The square root of 9 is 3. The square root of x to the 8th, if you divide its exponent by 2, it's x to the 4th. I underlined the wrong y. Sorry about that. The square root of y to the 6th, if you divide its exponent by 2, will be y cubed. Left under the radical will be the 10 and the y at the end. From here, I simply multiply the negative 2 and 3, which gives me negative 6, and drop down everything else. So you just need to be careful, and sometimes it helps to look at everything individually, and then at the end you can put it all back together. And this completes the lesson on multiplying radicals with variables.